Hello and welcome back. We now focus on how we do regression tasks with machine learning. In this example, we use a very simple wine quality data set for a simple regression task. The data consists of a range of features such as acidity or sugar levels, pH values, and so on, and the aim is to predict a quality score in the range of 0 to 10. The data originate from this paper here. Note that the score is based on integer values, so we really are faced with the decision now. We could either treat this as a regression problem, as we will do with the following year as an exercise, or we could do it as a classification problem with up to 10 different classes. The original paper considered this as a regression approach, and so we will do this here as well. But you really need to think about whether or not this is a good way to do this. Again, we obtain the data from the archive where a lot of machine learning data are stored, and have a look at the data frame that we obtain from this, and you can see all these data are numerical already. We can use the inbuilt describe function to, for example, count how many data points we have, the mean, the standard deviation and the most important quantiles of the distribution of all these data points here. Again, the first step is to do some exploratory data analysis to get a feel for what the data looks like and how the different variables behave. Since they're all already in a numerical format, we don't need to rely on any special capabilities. We start with the univariate analysis. That means that we look at single variables at the time and look, for example, at the wine quality. If you remember, the wine quality is our target variable. This is the score that we need to predict. And as you can see, although in principle we have the range from 0 to 10, only the range from 3 to 8 is really used. And in this range, only 5, 6, and a little bit of 7 are actually used. 3, 4, and 8 are rarely assigned as a wine quality. We can already see that this will likely create some problems later on, because these two classes, and maybe this one as well, have so many more entries than the other ones. So it's very difficult to predict a wine quality of 3 when we have so few cases in the training data. Let's look at the alcohol content just as the distribution, and now we explore some correlations. Pandas provides us with a convenience function to create the correlation matrix, so we can call it df_core, and if we only want to look at a few variables, we need to specify the variables here as options. And then we use Seaborn as the visualization package to create a heat map out of this, and we also put anode equals true, and that means that we put the values in there. If, of course, we have many variables, this becomes impractical, but since we only have a few of them, the heat map here from the correlation matrix gives us a good idea of how the variables are correlated to each other. As we can see, some of these variables are quite strongly correlated with each other, but only really 3 variables have a high correlation with the target. So what we want to look at is the wine quality, and the most predictive variables will be those with a high correlation here, and for example here, the one with 0.1 and minus 0.1, maybe 0.2, will likely not be very predictive in our model. You can also do some scatter plots, for example, the acidity and the alcohol content, and see how those behave. We have the hue as the quality, and we can see where the high quality wines are. And we can also explore some more correlations. Now we can do a contour plot. Remember that we can plot all variables against all others. Here we only focus on those which have a high correlation, and then we can see how those quality indices behave. You can see that the distribution is different depending on the wine quality. For example, the alcohol distribution depending on the index is quite different, but you can also see in this contour plot that depending on the quality, you have different behavior of these variables. So these are plots that are quite illustrative to see how the variables behave. Now that we've finalized our exploratory data analysis, we move over to the machine learning part. And we follow the typical scikit-learn approach. We create an instance of our model, then call fit, and then call predict. As an example, we will use the random forest regressor, and we need to split our data into training and test data set, and look at the features and the labels. Like the target, this is our label. It's the last column, the wine quality in the data frame. Right? So this is what we need to do. We need to take the training columns, that is everything apart from the last one, and the label, this is the last one, and split it up into X and Y. So we have the X as the training data frame, and Y is essentially the labels. And then we can split this into test training, using test training split into test and training data. Again, we use quota of the data for testing. Now we define and fit our model. So we create an instance and define the hyperparameters, call fit, and we append the predictions to the test data. So we make a copy of the test data set, call the predict method, and append the two labels, this test data and our predictions, so we can compare them side by side. Now we look at the evaluation of our model and start with some global metrics, for example, the mean absolute deviation and the mean square error. And more importantly, now we look at the residuals. So the residuals give us an indication of where the model doesn't perform very well. Ideally, we would have something around 0 and randomly scattered. And you can see, because of the behavior of the data, this is on these slanted lines. So we can see that the evaluation of the residuals shows that the prediction clearly has some issues, in particular with these slanted lines, and it's not really unbiased around a residual of 0 as we would like. But as we said, this is an artifact also of treating this data set as a regression data set. We will probably be better off to discuss this as a multi-class classification. Now we look at the profile plot and see in which range the prediction works quite well. And we can see that towards low predictions, we have a significant bias in our model. And this is what we also expected from our initial exploratory data analysis, because we have so very few data points in here. So the model essentially learns that most wines are of quality 5 and 6, some of them a bit of 7. We see that we don't have a prediction of higher values and lower values. And if we scroll back up there to the distribution of our wine quality, we can already see that we would have expected such a performance from our model. So if, as a data scientist, we are faced with such a situation, we now need to step back and rethink our approach.